All right, guys, in this video, we're going to introduce something known as a related rate, which is essentially just a derivative, but with respect to time instead of with respect to x like we've been doing in this course. So let's review real quick. If you have a derivative with respect to x and it's of x squared, that would just be a normal power rule. So move the 2 to the front, subtract 1 from the exponent, and that would be our derivative. That would be it. But if it was a y squared, well, we treat it just like x squared, but its derivative would then have a dy dx at the end. Right? So that's implicit differentiation that we covered ways back. Now what we're doing, though, is we're taking derivatives with respect to time. So none of these are the variable for t or for time. So when I take their derivative, I would have to multiply all of these by d something over dt. In this case, it would be dx over dt. Y squared would become 2y, and then multiplied by dy over dt. And if it was something like the radius squared, well, the radius squared is just like x squared or y squared, so its derivative is 2 times r, and then times that dr over dt. Okay, so same thing we've been doing, there's just that extra step at the end here. So let's say a couple of equations, and we're going to take the derivative of both of these here. So we've got one that's an area formula. I think that's for a hemisphere, the surface area of a hemisphere, and this is the volume of a cylinder. All right, so taking a derivative of this, the derivative of A, we're going to refer to as dA dt. Now, on the right-hand side of the equation, all of this is a constant being multiplied. So remember, you don't take the derivative of a constant being multiplied, you just bring it down. But h, think about that if it was just like x to the first, right? X to the first has a derivative of 1. So h has a derivative of 1 times dh dt. All right, that's the derivative of our first term. Minus our second term, again, pi is a constant, so it just stays there. H squared is like x squared, so it would become 2x, or in this case, 2h. But again, we have to multiply by that dh over dt. Anytime you've taken the derivative of any of these variables, it's d something over dt. All right, so this is our derivative here. And that's all we're doing in this video, is just taking the derivative. But eventually you're going to be given, so let's see, there's 1, 2, 3 variables, right? h, dh, dt shows up twice, and then dA dt. You're going to be given 2 of those 3. You got to solve for the third one. All right, but that's going to be what the next video is about. All right, next one. So we've got pi r squared h. So we have 2 variables that are next to each other, right, being multiplied. Being multiplied. So this is going to be a product rule, okay? So our left function is pi r squared. Our right function is just h. The derivative of those two, so pi r squared becomes 2 times pi r dr dt, and the derivative of h would just be dh dt. All right, so again, product rule, we multiply these two, we multiply those two, we put a plus in between. So v, its derivative is dv over dt. And again, taking the derivative of a product, we have to use our rule here. So I'm going to do 2 pi r dr dt multiplied with h, and then plus pi r squared times dh dt. All right, so that's the derivative there. Again, eventually there will be, like, we're going to treat this as a variable, r as a variable, dr dt as a variable, everything as a variable, and you're going to be given a lot of information and have to solve for something in the equation. All right, so that's mostly it for this video, but just to go over a few things of kind of what's coming up. So in the next video you guys watch, there's going to be a bunch of word problems. All right, anytime you see the phrase rate of change of something, that's telling you what that d something over dt is. So for example, if the problem says that the area of whatever Okay, but the area of something is changing at a rate of 2 square feet per hour. That's telling us that dA over dt is 2. All right, so there'll be, again, a word problem. You have to kind of comb through and read and know that if you see something like this, right, it's really the rate means derivative. So it's the derivative of that thing with respect to time is that number. Now, in addition to that, a lot of the problems in equation will be given to you, but there are a few cases where you just have to recognize, hey, based on the shape, I know a formula for this shape. All right, so for example, if the problem involves a right triangle, sometimes we use Pythagorean theorem when we're talking about the 3 sides of a triangle. So if it's talking about the 3 sides of a right triangle, this will be your equation right here, Pythagorean theorem. If the question's talking about the area of really any triangle, this would be our formula instead, right? And so if it's a right triangle, they're not going to give us the formula. We have to kind of like decode from the question by using this one or this one. If it's a circle, so a couple formulas for circles. We know that the area of a circle is pi times the radius squared, and the circumference of a circle is 2 times pi times the radius. And again, if the question's talking about the area of a circle, we're using this one. If it's talking about the circumference of a circle, you would use this one, obviously. All right. And the last one would be for a rectangle. We know that its area is just length times width. All right. So again, most of the time, the equation will be given, but there are going to be problems where there's no equation, and you just have to, based on our knowledge of these different shapes, pick the correct formula. Okay. So the next video will have those examples. I wanted to introduce this because we put it all in one video. It's a lot. But from this video, the main takeaway is just how do we get the derivative of these different equations here. All right, that's it for this one, guys. Stay flawless.